Thanks for joining this talk. Today, I'll be covering a case study of a hidden bug in tiered Kafka. My name is Connie, and I'm an engineer on the data platform team at Rivian and Volkswagen Group Technologies, a joint venture between Volkswagen Group and Rivian that was formed in November 2024. A bit of context. Volkswagen Group is the largest automaker in Europe, and Rivian is an EV maker in the US that creates adventure vehicles like the R1T, R1S, and R2, the midsize SUV expected to launch next year. Through this joint venture, the companies are building a next-generation architecture and best-in-class software for both companies' future EVs, which means that our technology must scale to hundreds of thousands and millions of vehicles and must be flexible enough to cater to different brand and vehicle model requirements. The issue that I'll be discussing today happened within the Rivian data platform last year while migrating to a tiered Kafka cluster. Before I dive into the technical details, here's data platform at a glance. Our data platform can be broken down into three major components: the data, the pipelines to process the data, and the consumers of the data. The data itself is vehicle telemetry data, signals like state of charge, estimated range, door closures, diagnostic signals. Then we have the pipelines that will anonymize, standardize, normalize the data, and also certain pipelines that will filter signals based on conditions. And of course, there are the consumers of the data. Teams like the mobile app, fleet management, charging, service and diagnostics, and general analytics use cases that can be served through Databricks. Our architecture is fairly complicated, but for the sake of time, it can be boiled down to this diagram. On the left-hand side, we have the vehicles, which sync their telemetry data to a very well-named sync microservice. The sync service writes the data into a raw data topic in Kafka, where a Flink job will process, standardize, normalize the data. That process data is written to other topics in Kafka, where Druid, Apache Druid, our time series database will ingest from, and other consumers will also ingest from their topics. So for the scale of data platform, this is a graph of the number of messages received in different Kafka topics across data platform for Rivian. There's a strong daily pattern where traffic rises during the North American daytime when cars are out and about, being driven, generating data, and then a minimum overnight when cars are mostly parked in garages and sleeping. The largest topic receives 6.5 million messages per second at the peak. So as we scaled, thousands of new cars being produced every month, we realized that it was not cost-effective to be running with a fully local storage Kafka cluster. I think this is a decision that a lot of companies make once they reach a certain volume, which is why tiered storage Kafka solutions have been on the rise. So we planned a migration meant to be executed in a few different phases, with some smaller topics moving to the new tiered cluster first and more critical workloads last. But then as we were in the final phase of production migration validations, we ran into an issue that we hadn't previously seen in any of the lower environments or testing we had done. We got an unknown server error when trying to start a new consumer on the tiered storage cluster. This is the exact error message: unknown server error while fetching offset blank for topic partition obj prod. And even more unfortunately, this bug did not just take down a single consumer, but actually caused a failure on multiple brokers that affected every consumer that was trying to read a partition on any of those brokers. Since we knew which consumer was causing this error, we quickly turned it off, but then we were stuck. What could be causing this? We tried a few more times during off-peak hours, but the same thing happened every time. And then we found out that if we started the consumer from the latest offset instead of earliest, it would be totally fine and start ingesting data normally. The unknown server error only occurs with a new consumer reading from earliest. And interestingly, it only happened after there was a certain amount of data in the cluster, which is why we didn't see this in the lower environments. So before I go into what the issue was, let's discuss Kafka transactions. What are transactions and why are transactions needed? The short answer: Kafka transactions provide atomic operations for groups of messages, ensuring that they are all committed successfully together or all rolled back as a unit, similar to database transactions. They're particularly useful for guaranteeing exactly once semantics, which guarantees that messages are processed once and not duplicated. And the way that this works in practice is that there are 3 states of a transaction. First is undecided or ongoing. Second is decided and unreplicated, or prepare commit, prepare abort. And the third is decided and replicated, which is complete commit or complete abort. So this is all handled through a process where the state is tracked by a series of control records written to the transaction state topic. Every time some data is written to a new partition inside a transaction, the ongoing state is updated to include the list of involved partitions. When the transaction completes, we have the prepare commit or prepare abort state change. And then once the control record is written to each involved partition in the transaction, we'll have complete commit or complete abort state change. So if a transaction cannot be completed atomically and is in the complete abort state, there must be a way to tell clients that certain offsets that were produced to the topic already were part of an aborted transactions and should be skipped. So transactions rely on a client configuration to ensure that clients behave properly. The client config is isolation level. So this determines what transaction records a consumer can see. And there are 2 options, read committed and read uncommitted. Read committed ensures that consumers only see messages from transactions that have been successfully committed, while read uncommitted allows consumers to read all messages, including those from aborted transactions. We're currently not using any transactions in any of the Rivian topics, but this is where our problem originated. The specific issue is in open source Kafka's tiered storage implementation. So there is an open KIP for this, KIP 1058, and these are the relevant excerpts. When the consumer enables isolation level as read committed and reads a topic with no aborted or committed transactions, then the broker has to traverse all the local log segments to collect the aborted transactions in the worst case, since there won't be any entry in the transaction index. The same logic is applied while reading the data from remote storage. In this case, when the fetch request is reading data from the first remote log segment, then it has to fetch the offset, time, and transaction indexes of all the remaining remote log segments, and then the call lands to the local log segments before responding to the fetch request. So essentially, each broker has a thread pool that is used to scan the log segments to fetch offsets. When there's a read committed user, the broker must scan offsets to look for committed transactions before it knows what to return. In a local storage Kafka cluster, the scan is relatively fast because everything is stored locally. But in a tiered cluster, this can tie up the threads in the broker scanning all the offsets in the remote log segments. And I think that has a timeout set to around 15 minutes. So a read committed consumer starting from the earliest offset on a topic that does not have any transactions will need to scan all the log segments in the topic to look for a committed offset, which means that if that topic has partitions on every broker in the cluster, one consumer can exhaust the thread pool on every single broker and cause the whole cluster to become unresponsive. And unfortunately for us, the Druid Kafka consumer, Druid, which is our time series database, defaults the client config to isolation level read committed. And so what was the solution? Even though we found the root cause of this unknown server error and changed the config within Druid, we ultimately decided to cancel the migration. Knowing that a single misconfigured consumer could take down a whole tiered storage Kafka cluster made us very hesitant to move our very critical pipelines into tiered storage. As a platform team, we don't have full control over all the clients that connect, and so that was a risk that we were not willing to take. It's one thing to achieve some cost savings, but it's another thing to knowingly make your platform more fragile and vulnerable to a single client's misconfiguration. The second step was evaluating other cost optimizations that could achieve our targets by reducing retention on topics on our local storage cluster, adjusting the instance types of the brokers we're using, et cetera. And the third step was exploring other technologies, which is how we found Redpanda as a viable alternative that solved our performance and cost requirements. So in conclusion, as a platform team, we don't have full control over every single Kafka consumer that's ingesting data from our cluster. And this makes it extremely difficult to enforce any kind of client-side behavior. It is also important to maintain centralized communications with all the client teams. We were already in production with dozens of consumers before we found this bug. And so we had a difficult period of checking and requiring every single client consumer team to verify their isolation level config. And that config is not readily apparent for certain client libraries in less popular Kafka consumer languages. Also, it is very important to carefully test all production use cases at scale. In this case, it is very important for us to be able to start new consumers from earliest offsets in case we have a new use case that needs data to be backfilled and can't just start from latest. We had tested this in the lower environments and in a limited way in production, and everything was working fine. And in fact, we only discovered this issue because the number of log segments in remote storage hit a certain threshold where scanning all the logs took more than a few minutes. And then as we evaluated Red Panda, we spent a significant amount of time and resources to ensure that the performance at scale would solve our specific use cases and that we wouldn't run into any bugs like this. And then last, performance versus cost optimization is a delicate balance and a constant tension within engineering orgs. The balance and compromises that need to be made depend on the organization and the team and the budget, but it is imperative to understand how you value performance and stability versus cost savings. This ended up being a small bug that's an edge case for mainstream Kafka, but it is actually a fundamental use case that my team needed to be able to support. And there were actually other technical issues that we ran into with open source tiered Kafka that led us to migrate off of tiered storage and onto Red Panda. But this was one of the hopefully more complex and more interesting ones. So thank you for joining. I hope that you learned something and found this talk informative.